So first thing I want you to do is take your piece of paper and fold it in half, please. It was landscape, and we folded it in half this way. I'm so confused by that, because when do you literally fold a hamburger in half? You don't. After you fold it in half, I want you to take each half and fold it back up to the place where you just were. You understand what I'm saying? And if you don't understand what I'm saying, do you understand what I'm doing? Yeah? Okay. Okay so far? Then fold it in half this way. Ready? Take your scissors and cut on the folds that you just made. Just the front part of it, though. See how I only cut to there? Same thing on this side. So that I have four little tabs that I can open. Before we go any further, flip it over on the back and write your name. Absolutely. It was my name. All right, everybody okay so far? Okay, so notice where I'm starting, please. I'm starting at the bottom left flap. I'm not starting at the top left. I'm starting at the bottom left flap. Okay, I zoomed in quite a bit so you could read a little easier what I'm writing on each flap and inside each flap. Okay? Complex numbers. What do you think people automatically think about this when they see it? It's hard, right? Because the word complex, the word complex actually doesn't mean hard. It means multiple parts, right? So a complex number actually looks like this. A plus bi. And because of where we need to go in a second, go in here at the bottom of this and put graphing. Now let's open the tab. Now the fold makes like a natural divider. Do you see that? So we have two sections right here. In this first section, we're going to talk about the definition of complex numbers. Okay? Complex numbers are written in the form A plus bi, where A is the real part and B is the imaginary part. So yes, I'm going to give you homework on imaginary numbers. That doesn't mean you need to bring me back a blank sheet of paper and say, here's my imaginary homework. Okay? It would also get you a 0. Yes, it would be funny. To me, not to you. Okay? Real part is A, imaginary part is I. So can anybody guess why we use an I to notate the imaginary part. Oh my gosh, it starts with imaginary. Okay? Also, but I want to be picky about this. Please notice how I'm writing my I. I'm not writing it that way because I'm a girl and I want to write pretty. First of all, I already do. Second of all, we need to write it like this because if I just wrote it like that, what does it look like? It looks like a 1. We don't want to get confused about whether I'm writing an I or a 1. So we're all going to write it like this. And in fact, if we typed it, it would be in italics. Okay? So if you know how to write in italics, write that in italics. Okay? All right. This is one of the places where we need multiple colors. So if you have multiple colors or if you need them, please have them out and ready. What do you think we're talking about now? Graphing. Okay, excellent. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We cannot graph a complex number on a typical coordinate plane axis. We have to graph it on a complex axis, where this axis that runs horizontally is actually the real axis, and this axis that runs vertically is actually the imaginary axis. So this point right here is actually called 2 plus 3i, because I went over 2 on the real axis and up 3 on the imaginary axis. What? Yes, it does. That's one way you can easily know which part is the imaginary part. If it has the I, it's the imaginary part. Okay? So first thing I need you to graph is 3. On a coordinate plane axis, can I graph 3? I cannot, can I? I have to have an x and a y coordinate. On a real and an imaginary axis, can I graph 3? Because real is 3. What's its imaginary part? 0i, right? So I just go over 3 and I put a dot. What about 2i? What's its real part? 0. So I go up 2 on the imaginary axis. So what about 2 minus 2i? Where am I going? Give me directional words. Over which direction? To the right 2? Down 2. Why is it down 2? Because it's negative, absolutely. One more. -1 minus my favorite imaginary number. It was my nickname growing up. Yeah. Yeah. It's fine. How do I graph it? Left 1. 1, 2, 3, 4. Do you get it? Okay, just making sure. It was just a little joke. We have a little bit of room on this first part, so we're going to write just a reminder to ourselves. The real axis goes which direction? Left and right. The imaginary axis goes which direction? Up and down. Okay so far? So let's close that. Oh, sorry. Okay, so we're going to close that and go to the one right above it. Okay. Again, because of the fold, we have two natural sections. Okay, let's write on the outside of this first before we go too much further and talk specifically about imaginary numbers. We're going to write two definitions here on the outside and then go on the inside and talk about them. Okay. That's the most important definition you need to know, because you could actually figure this one out if you don't remember it. If I is the square root of -1, what is I squared? -1. So, you remember how when we were doing problems in the past and you got an answer that was the square root of -4? What did you write after that as your actual answer? No real solution, right? Because there's not a real solution when you have the square root of a negative number. That's because there's an imaginary one. And after today, you're going to know what to do now. Okay? So let's open this up. Again, like I said a minute ago, there's two natural sections in here because of the fold. So on the left-hand section, let's write a definition. The imaginary unit called I is defined by I equaling the square root of -1. So let's do some examples just with that problem. Now, before I do some examples, let me ask you some test questions first, so that when we actually do some examples here, we get the right answer. Okay? We've talked about this in the past. I'm just trying to remind you. What is the square root of 9? So I'm saying what times itself equals 9, and you're telling me 3, and I agree with that, but also -3, right? So how do we typically respond when we have that then? Plus or minus 3, right? So let's try this again. What's the square root of 9? Plus or minus 3. What's the square root of 64? Plus or minus 8. What's the square root of 196? Oh yeah, you remembered. It's on the board, right? Plus or minus 14. Okay? I had to look at 196 to remember, because I almost said the other way around, but as it turns out, it would have been fine, because that's 13, right? Okay? So if I ask you the square root of 25, you're not going to have any trouble saying the answer is plus or minus 5, right? Okay? So now let's look at the examples for today on this section. What is the square root of -4? Well, up until now, we've always responded with no real solution. That's because the solution is imaginary. Okay? I need you to remember your properties of square roots, because properties of square roots say I can do this, right? I can separate it into parts. Do you remember that? What is the square root of -1? What's the square root of -1? Look at what I'm pointing at right now. What's the square root of -1? I. What is the square root of 4? Oh my gosh, I just went through 18 examples of what the square root of a number, and then I ask you the square root of 4 and you say 2. Oh my gosh. Let's try this again. And I won't grunt or growl at you anymore. What is the square root of -1? I. And what's the square root of 4? Okay, excellent. So I get plus or minus 2i. You guys are so funny. Do I have to do this step if I can do it in my head? No, you do not. Okay? What about this example? What about the square root of -45? Now, do you know the square root of 45 off the top of your head? No, so we got to break it down, right? So I'm going to choose to break it down like this. I'm thinking in my head, what two numbers multiply to be 45? I can think of several different combinations, but the one I want to choose is what? Why do I want to choose 9 and 5? Because I know the square root of 9, right? I want to choose numbers that I know the square root of. I could have chosen 3 and 15, right? But I know the square root of either one of those. So I want to choose 9 and 5. Now, what's the square root of negative 1? I. What's the square root of 9? Plus or minus 3. And what's the square root of 5? I don't know either. Okay? So we need to figure out what order we write everything in, don't we? Because does it really matter? Does it really matter? No. But there's like a more appropriate way to write the answer. Okay? How did I write it up here? Whole number first, and then the imaginary part, right? Is I a variable? Does it change value? Or is it always the square root of negative 1? It's always the square root of negative 1, right? But it's a letter, so sometimes we actually treat it like a variable. So I'm not going to write very often I2. I'm not going to do that because that's not the way we typically write stuff. Okay? So I know I've got to write an I know I've got to write a plus or minus 3, and I know I've got to write a square root of 5. If I write square root of 5I like this, is the I inside or outside of the radical? I don't know. You can't tell, right? So where do I want to write the I? In front of it, right? So how do you think I'm going to end up writing my answer? Plus or minus 3I root 5. Good. Now, at the bottom of the section where we still have some space, I'm going to use orange on purpose. What does orange typically mean? Caution, beware. And it helps if you growl when you say it. It's fine. Okay? I need you to be very, very careful that you don't make this mistake. Okay? Negative square root of 2 does not equal I square root of 2. That is not true at all. Because where is the negative sign? On the outside. When do we care about the negative sign becoming an I? If it's inside. Okay? And in fact, negative square root of 2 actually equals negative square root of 2. That's not something you can simplify any more than it already is. Okay? Got it? So just be careful about that, all right? Now, in this little section right here, this next section that's right beside it, I'm going to draw a picture, and then we're going to talk about it. So let me draw it, you draw it, and then we'll talk about it. Is that all right? Okay. And for the record, I'm using 3 colors in this picture, if you care. The arrows are purple and the writing is blue, just so that they stand out a little bit. And for the record, I know that's only 2 colors. I'm about to write in the third color when we talk about it. Okay, so I know at least from here to here that makes sense to you, right? I, if you multiply by I, you get I squared. If you have I squared and you multiply by I, you get I to the third. If you multiply by I, you get I to the fourth, right? Everybody okay with me there? Okay, so I'm asking you this. If I take I and multiply by I get I squared, correct? But what does I squared equals? Negative 1. That actually equals negative 1. And I know that if I take I squared and multiply by I get I to the third, right? except I know I squared equals negative 1. So what if I multiply negative 1 by I? That equals negative I, doesn't it? And I know that if we multiply I to the third times I would get I to the fourth, right? But I know that I to the third equals negative I. So what if I multiply negative I by I? Negative I squared, right? Except for the fact that I know that I squared equals negative 1. So that's negative 1. So here's what I want you to understand. If I take I to the fourth,